All right, so anyway, welcome to the course tonight. This is basically a preview course of what the program is that we offer here at ACS. This is the PACS A to Z series, and what it has is the two-part course, the 2 days, first 2 days of it. This is a 3-day class. I teach the first 2 days of it. The first one is basically introduction to PACS administration. It for the people who really have no practical experience in PACS, other than if they are a healthcare professional and have been using the PACS in their job, that is a good idea. And this will be the next step. If you were to get a job as the PACS administrator or you wanted to get one, I'm going to show you how you can survive or actually learn all of the skills needed to do the work that's necessary to be a PACS administrator. And if you are already a PACS administrator but want to learn more about it, go deeper into it, maybe there's parts of it that you don't understand, we will do the basically the CIEP review or the PACS boot camp. And that has all of the contents in both the CPAS for the PARCA as well as the CIEP exam. We tailor the class to cover those content items that they publish on the website. So you'll be prepared, but even if you're not interested in taking the certification exam, it is still a very comprehensive overview of what all the details of a PACS administrator job would be like. So normally what I'm about to show you is covered in 2 9-hour sessions in 2 days. So I'm going to go over for about 30 minutes, mostly what the content is about. So if you want to see what is in it, that's what you're going to see tonight. So I will just move along here. So I think we've got most people here. And at the end, we will have some discussion. What I'll do is I'll basically unmute everybody and ask you to raise your hands. And I'll go in the order of the hand raisings and give everybody a chance to ask the questions. And, if you can get back in line and ask more. So that's kind of the plan tonight. So anyway, let's get rolling. Thank you very much for your attention and attending tonight. So first thing, introduction. These are some of the actual slides from the program and that you will see. So this right here would be the start. It's part 1. And here's what a general schedule would be for the course. So basically it starts early and it ends late, but we actually do that for a reason because we can get a lot of content in those 2 days. So maybe you'll be worth the travel if you go on site, or you will only have to put in 1 day to get the 9.5 hours. So the idea is after 3 days, you really get 4 days worth of training in most everyone else's course, but you don't have to spend the travel time and support time. So that is why we think it's a better value. Also, I think sometimes it's better just to go through it all at once rather than break it up. But that's up to you. So we do follow the ACR. I'm not going to read all of this because it's category A, CE, ECE credits. The entire course is I believe around 38 credit hours or ECE credit hours. So just the first part is 10.5. And we have evaluations. So we always are trying to improve. So we take the feedback seriously. Certificate you'll get at the end of the course within 5 business days on a share file. And then there's the coordinator that you see, ACS. Those are the ones that you can get for support in case you're having technical difficulties or if there's any more information you want to know. All right, so I'll get started. Who am I? So one of the things I think is real valuable about the course is those who are teaching it are the ones who are actually doing the job. We actually have done the job for quite a long time. So right now, my job is actually an IT manager or engineer in enterprise imaging, or I'm a PACS engineer or architect. So I have been in PACS more than 30 years, actually starting in 1992. I guess that's about 34 years now, or going on. But I have I basically started out as a clinical technologist. Then I went to educator, which I was program director of the school for 3 years. That's how I knew I liked to teach. And then I became radiology manager. So here's me as a student. Here's me in sales, because I was 10 years commercial, a PACS engineer in sales. And then 21 years in PACS. I got my CIIP, became PACS administrator for 13 years, and now IT manager for PACS. And then they decided that I needed to be a PACS engineer. So I started that about 6 months ago, and now we have another manager. So it's a manager and an engineer because we're getting bigger and we're doing more things, and I have the background for it. So I got my Bachelor of Science in Radiologic Sciences, but I also have a Master's in IT. So I've been in kind of a little bit of all of it, and that's why, so you can ask me questions. And that is a lot of the content that we have designed is to meet the needs of all these types of professionals. So let's move along. So anyway, I have also used to be a item writer for the CIP exam. So the mock tests and the quizzes are actually all written in ABII format, or at least the way I believe it is. I don't see the actual test questions that go out on the exam, but I do understand how they're structured. So I can't reveal the whole part. So I basically, you can read that for yourself. Okay, so what is expected of a PACS administrator? Is one thing to start out was like, do you really know what you're getting into? I'm going to describe the job a bit more. Like, where did PACS administration come from? Really came from people who got off of using film and getting onto computers. There was nobody like that who could actually work in both worlds, and that's kind of where PACS administration came from. And then what do? We got to make sure you have access to the images at all times, on every device, at any time, in any place that you want them. And it's really what the demand has gotten. And unique about the roles, we see everybody work so we can improve the system, and that's how we make a difference. So we will spend some time talking about that. I do think it's important that you understand what is expected of you. And I've done the job for 30 years, so I have my own opinions. I can help you with it. First, what is the picture and archiving and communication system, which is what PACS is. We will go into each of those parts, and you'll see how it fits throughout the program. If you learn nothing else, learn that. Now, one of the things that most PACS, people who are interested in PACS are, is they fear, do I know enough about IT? Do I know enough about networking and all of the standards and everything that goes in putting a large system like PACS together? So what I'll do is, it won't be, the first day is not that heavy duty, but it is the parts you actually do need to know. So you can't, you won't be able to get it in one day, but I will show you how PACS administrators team with IT professionals and networking professionals to keep the system running. So how much IT do I really need to know? That is going to be the focus. And you'll find yourself being much like this gentleman, who is, you're in hands in so many different worlds, but you're the connector, the glue that keeps the clinical technologists, the radiologists, the rest of the hospital, and the IT people with a working system that has useful information in it. Then the lab does it, the pharmacy does it, all the other departments. So we're just one of the framework of healthcare, but very important. Okay, so now how do you understand how a computer works? Well, if you understand how a computer works and how the users interact with the different programs and the hardware, then you'll understand how to troubleshoot what the problem is. First, you have to understand the workflow. Once you understand what is going on inside the computer, then you will be able to find out when they call you and say, I can't do what. Now you figure out which part is it. Is the application, which is PACS, or maybe the electronic health record. The operating system, it can be Windows, Macintosh, or Linux. And then hardware, if your hardware doesn't work, you're not seeing any of this. And then what could possibly be a user error or a user issue? And, that is something, a technologist or somebody will call you up and say, I can't get into the PACS, or I can't do whatever. You have to listen real carefully and find out what they're telling you, because they give you great clues. And I will show you at the end of this some of the troubleshooting we will actually practice once you've got a better understanding of the PACS. So the C in the PACS is the communication. So that's the network and controls the network. So one of the things, PACS administrators, they do not repair the network. We're not going to go in there and get a network sniffer and go and try to find out why the network's broken. But what we will learn is how to tell which part is broken. Is it the wide area network that the radiologists are using when they're reading at home? Is it the Citrix system that is running, a server-based system that they're getting access to it? Or is it the standalone workstations? Or is it the local network that is in the building? Or is it something else? Maybe it could be Wi-Fi. Maybe it could be all that. Once you understand what the person tells you, what they're using, look at the equipment, then you can say, okay, I think it is a network issue. And you're going to go and you're going to put in a ticket and saying, I believe this person is pushing a wireless digital portable, and they say that they can't send any images on the second floor. That right there is volumes. Right there, they can go right to the problem. But you can ask very clearly after you have done enough understanding of what the problem is, And then so you need to know what to ask for and who to ask. And that is what you need to know when you're first new PACS administrator. You will learn what they're talking about as time goes on and learn how to speak all of this. First, you know networks, two computers communicating over the network. That's exactly what it is. You have to remember what makes one not talk to the other or neither of them talk. And that's when you start to figure out things. But most of the time, networking is set and forget. Once you get it going, get it running, then you have to look at what changed. Or otherwise, if you don't change anything, it should stay running as long as you want it to. Local area network is basically the same building or floor. Wireless is the same thing, but it's on no wires, no cables, except for what cables to the access points or the transmitters. But the device you're working on is not tied to it. And then there's virtual LANs where you can have different circuits. Like that's why the electronic health record and the PACS can run on the same cables. But you have to program them right, but it can be done. And then wide area network is spanning outside the facility, going to either the support network, or maybe you have an archive that's in the cloud, or radiologists who are reading off site. And then virtual private networking is how you get in from home and maintain your security. So, of course, I'm going to take a lot longer describing all of those things, but that's just kind of, the network is extremely important, and that is actually probably a lot of the test that you're going to take. So we're going to look at how the providers work. They're going to use their own computer with the Affordable Care Act and the regulations that came in lately in the last 10 years. It now requires the physician to do their own ordering through their own computer. And we're going to go and talk about that workflow and how we can reduce poor handwriting and basically medical errors because the physician is now in the front. But we made it easy for them. We'll just talk about that. Okay, so how does all of the information get in and form the clinical informatics workflow? Because that is what we're trying to do. We have the medical staff entering orders. We have the imaging staff taking those orders and making images, putting them into the PACS system. But then you also go in the RIS system and you complete your orders, you add notes, you may be charged for supplies. And then you have your medical records or your health information management, who is getting maybe outside images imported, or maybe the whole patient's chart, and then maybe that patient's going to transfer and they're going to go out. But this right here is the process of how everyone's contributing to the clinical informatics process. And when you understand that, then you can help troubleshoot the rest of the hospital who's trying to use your PACS system. Now, moving along, DICOM. If you're somebody who's an imaging professional and you're using an imaging device, I'm sure you've probably seen that name somewhere in your software. But that is the standard of how we connect and can take CT scanners, ultrasounds, nuclear medicine, mammography machines from many different vendors and use this standard to be able to send images to your PACS system. And when you understand the standard, you'll know how to use the information to set up a new modality on your network and how to make it communicate on the network. Then you're going to program the DICOM information so that way it can share with other DICOM devices, either on site or off site, or maybe sending DICOM information to another hospital where that patient went to a year from now or maybe a year ago. And that is how the new world goes. So this is the big standard. Another standard we use is HL7. That's the start of the patient care imaging workflow. So all of the hospital IT systems run in HL7. It isn't exclusive to radiology, but it has admissions, order management, report generation, and then uploads to the EHR, and also sends the links so you can see the images in the chart, and then also statistics on how you utilize that data in other systems and pass it around. So there's the two big systems right there you need to understand in PACS administration, and we will go over it to get you going on your way. Now, how do you pull it all together? Now, this is the imaging informatics data flow. Notice I changed the name from PACS because when you're starting to talk about informatics, now you're talking about providers and healthcare professionals, nursing, all the other people who use your information. Here are your standards, your ADT, admissions discharge system. You have your HL7 information, your DICOM, and then your XML. I will basically go over in detail on this graphic how all the data changes hands when it goes through the different systems. One thing that a lot of people don't understand, the PACS is not a box. It's not one thing you buy. You don't get it on Amazon and drop it and then you plug it in the wall, plug in the network cable, now you have one. Although arguably there is such a thing in an orthopedic office if it just does one thing. But in the hospitals, the PACS and informatics systems are made up of many IT systems. And the ones that you have to learn about or interface with are the ones that you'll interface with, you share data with, and you're going to understand those interactions. And you're saying, I will never learn all of this. Oh, yes, you will. Because it actually makes great sense once you understand how everything communicates and also are able to listen to your users, understand where their troubles are, because you have actually walked that workflow yourself. Or maybe you were the one that designed it. So this is all of the different interactions. There's a lot of acronyms, I know, but isn't there in radiology also, and also in IT? Okay, now how's the picture archiving workflow process works? Where does everything start? One of the things I mentioned, there are different boxes, different systems. All of these things make the PACS. You get an order, then you have to get a pre-fetched exam from long-term storage, or maybe it's online all the time. Depends on what you have. The PAC technologists will get an order, and then they'll get modality work list. They'll be able to make an image and send it back to the PACS servers, which are going to make it available to the radiologist and web clients. Then the radiologist will do the reports on a digital dictation system where you speak into it and it turns into text. They will sign it. The final report will go back to PACS and also the electronic health record. And then you're able to distribute that image. You're able to make that image available to other healthcare facilities that patient may go to in their lifetime. So that really is kind of how it all works, and we will go over that in greater detail. And then you back up the system and you have it ready for the next time you need it. Now we'll go into the different parts. What do the servers do? What are they made up? How you build a server. I'm not saying you have to build it. You just have to know what to ask for. So you have the workflow manager that makes the work go in certain places, serves it up the way the person who signs on wants it. It also sets triggers from when it does one thing and does the next thing. So HL7 orders can come in, you sign the report, it triggers the report to be loaded, and that report loading triggers an image to be able to be seen in the electronic health record. So that is, instead of all these people making all this work and moving this data around, the computers are talking to each other, and that is what we get to understand why the servers do it. We'll learn what the software is, what platform is it on, how to use it, how to configure it. And then we look at the interfaces, how they get the modalities able to send the images to it. Then also to put on things like artificial intelligence, dictation systems, the CAD that's on mammography, and then possibly other things like needle-guided biopsies, robots, anything you can think of that can use the images that we're going to basically learn how to get that to work. And then I'll look at another part. Here's that diagram I just showed you, by the way. Now let's look at the workstations. I just showed you the server core. Now we're going to look at the workstations. We're going to be making the radiologist able to read, but it's going to be very automated and very integrated. They sign on the workstation and then it signs on everything else. They have the electronic health record. Every time they change the image, it's going to change to the page and that next patient's chart. They're going to bring up a dictation window. They're going to be able to fill in the blanks and sign it. And that's, once they're done, it'll go to the next patient. You're going to learn about the hardware and what hardware you need, what kind of CPU performance you need to do this. The vendor will tell you, don't worry, but you will know how to ask for it. And then you have high resolution monitors. You don't need the mammography monitors to do everything, but you'll need to know how many you need to do that. And then the auxiliary monitors. Report dictation, you're going to install that interface and radiologists will dictate on it. And then third-party applications, as I mentioned, the other systems. And then also the web client. So, radiology is just one part of it. There might be, you might have about 10 or 12 radiologists that are working. If you're a small hospital, maybe one or two, or maybe they're all off-site. And then you might be a gigantic health system like I work in, where you have 100 radiologists reading in one day. So that's one part of it, but you also will have the users who want to see your images. They're going to be all over the enterprise. But, to you, it looks like just one thing. But everyone else is getting on their phones, getting on their tablets, looking at the viewer through the electronic health record. Maybe it's something on a screen in the surgery center. Wherever an images is, that's where PACS can go. So the standard is, basically you got to come up with what is a good standard piece of hardware, and then you replicate that maybe 1,000 times so you can see images in 1,000 places. It all depends on how big you are. You're going to learn what software and how the images get displayed. So if the images break, you'll know how to fix what makes them work. And then also you'll look at the archive and how you store things and how you retrieve things. So that's a very basic, but there's a lot of users out there, and you have to figure out how to keep them happy. But you know what? Once you get the system running right, that's all you really need to think about. Okay, archive storage. Right now, there's multi-tiered. That's the part where you keep your images stored and safe. That's the A in PACS is the archive. And so you have short-term memory, you have long-term storage, and then you also have what formats you're sending in. You may have a vendor-neutral archive, which means you can store images in any format. So if you do an ophthalmology exam, it's your eye, you can store it in there and it's going to keep it in that format. If you store a DICOM image, it'll keep it in DICOM. The whole point here is that if you need to export that to another hospital or for that patient, that image is in the right format for that system to be able to use it. All right, and then you're going to be able to write the rules. So storage is important, but really standards keeping is the best. Then the fun part, where you're going to learn how all the different types of integrations you're going to need to do. So artificial intelligence is the latest one, but you may have to integrate pathology slides. You never know. There's lots of things make images. So we'll talk about that. Then the big thing, how do we support it all? So I now showed you what it is, a little bit about what makes it work. And understanding that is how you can actually go fix it, because when you know what it's supposed to do, you can look at what it's not doing, and then you go back and make it do it again. And that's really how troubleshooting works. So you have issue management, downtime management, and then disaster recovery, and then the troubleshooting part. That's when you're talking to the people who are having trouble. Troubleshooting, yeah, there you go. First, what is downtime? We're going to define that. Basically, this is my quote, because I couldn't find a really good one that I liked. PACS is affecting the patient care workflow, not patient care. People say, this is affecting patient care. Well, you know what? Every time you step in, put your badge on, and you're in a hospital, everything you do is patient care. So patient care workflow is what we're interested in, how you get information from one place to another. And downtime, the goal is to be able to function while in downtime to a level that results in minimal workflow change. You don't want to have to run around and tell the technologist, okay, here's what you're going to do now. You won't have time. You want to basically have a workflow that you can say, hey, we're going to secondary. And they look in their book and they said, okay, got it. And now they're able to do it. So that is how you can function in downtime. Scheduled downtime is when you're going to make changes to the system. And we're going to show you all the planning that goes with that. That is a good thing, because you can't just not change the system or not update anything. So this is something you're going to have to learn how to manage. And also unscheduled downtime, well, this is when you got to react quickly. You don't know automatically what's wrong with it because you didn't set it up. Something just decided to show its head and you had to go find out what it is. But you also need to create a downtime workflow so the technologists and patients can still be taken care of. And that's when you want to look at backup systems. So going into backup nature must be second nature to the staff, and we get to write those procedures. So we designed that. But with the real question you're trying to answer, and this is me troubleshooting a cardiology workstation, is where did it break? So yes, I showed you these diagrams, and it's very important to understand, is it an HL7 interface? Is it a DICOM interface? This one picture right here is your roadmap to figuring out how to support a PACS system, and you'll get more detail in the course. So, troubleshooting, this is an example of some of the live exercises we'll do. So I could say my modality is not sending to PACS, is PACS down? Well, what questions should you ask? First of all, did the modality fail sending to PACS, or did it say sent? Because that means it went in the PACS somewhere, it's just probably misidentified. So PACS is not down, but also other questions, is anyone else having trouble with PACS? If it's just that one modality, or is it everybody? So that's when you have to go and define the problem. So this is kind of how we have these interactive discussions and learn this. All right, that's part one. So part two is a little more of the same, but a little deeper. So basically this is called the CIP Review Bootcamp Overview, and this is a lot faster paced, kind of at the pace I'm going now, but we cover hundreds of slides. I mean, it's a lot of information, but then the exam you take is a lot of information. So it's just like anything else. If you understand the material, the exam isn't going to be that hard. Although I will say it's probably one of the harder exams I've ever taken. But that's why this is a very good profession. That's why it's a very lucrative profession. PACS administrators do get compensated well. All right, so here's your certificate. Just wanted you to see one. Here's what the test scores look like, and here's some of the things that you may not be aware on it, like procurement, project management, operations, but then the things that you do know, like image management, IT, systems management, clinical engineering, which is the modalities, and medical informatics, like HL7 and DICOM. So that's what the test is going to cover. And now guess what's in the course? So first of all, procurement, we're going to learn how to buy things. You're thinking, oh, this is crazy. Why do I care? Well, guess who they're going to ask about, what do I need? PACS administrator, tell me. So we're going to go over that, and you're going to assist them to buy the right thing. And if you don't think so, that's really true. Then you're going to look at how we're going to put a proposal together to see if we get the best deal. And that's called a request for proposal. We'll go over the parts of that. And then we're going to look at the types of contracts. You're thinking, why do I care again? No, because you're going to have to help these people because they've never bought a PACS system before, and you know more about it than anyone else. And that is the way of the world. Project management, once you buy it, now you got to get it to become real. You're not going to be doing the project. You'll have a project manager, either from the vendor or from your facility, but you're going to be the one answering the questions, getting the information for them, executing the tasks, or see that they get executed through other people. And that is your role there. So understanding the project management process is a very big deal. All right, so Gantt charts, these are ways to find out if you're on track. Are we on time? And why does this matter? Because they say, I need to be live at November 22nd. So these are all the steps. So I'm starting in August. This is how we're going to make it. We have to do these lines in their order, meet our timelines, and then boom, we're going to be live when we told the president of the hospital we were. Then closing the project, what I like to say is that going live isn't turning on the new system, but it's turning off the old system. What all do you have to do before you can go live? And sometimes the tasks can't all be completed because of different problems, backlog, other people didn't do their job. So you just got to understand, what is the minimum it's going to take to get the system going, and then everything else will transfer to support. I did project management myself, so I understand that. I also was in sales, so I understand how to sell things, so I understand how to buy things. So I can tell you firsthand some good ideas how to deal with this. Now, operations, that's one of the big sections. You need to understand how radiology and imaging works on the inside, what all of their challenges are, so you can assist them. You need to understand the quality improvement process or quality control. So we have to have good quality on everything we do. We have to make sure that everything's functioning properly. Computers are a little harder to tell. You have to rely on software, so we get to learn that software that does that. Make sure the monitor's displaying right, make sure the data is believable, things like that. Policy and procedures, you got to have policy and procedures on everything you do. These are going to be more like how the workflow works, what downtime procedures are. We're going to have a big hand in figuring that out. Now communications, you're thinking, what's that about? Well, here's one of the things. You're going to learn how the roles and everybody does things in the hospital. You're going to learn medical terminology. You're going to learn what availability means and how to communicate around the hospital when you're doing things, and then also how to do strategic planning. I know it depends on what your role is, your IT or your clinical. The medical terminology is going to be easy if you're clinical, but it's not if you're IT. So they do want you to have a basic understanding of when the physicians are talking to you, you can understand kind of what they mean. And then medical terminology, like I said, it's good to learn the secrets of that. And then also body planes, because you're putting together images displaying on the workstation. They're going to call them what plane they're in, and you really don't want to ask the doctor, what do you mean by that? You can do that a couple times, but after a while you have to figure it out. We go to school for a fairly long time, clinical, to know how the proper section imaging is. So then there's coding, because when you're doing interfaces, you got to make sure all these values are available and the physicians can see them. You're going to be looking at other terms that are not so much radiology, but SNOMED, and right here you can see it in the trademark of the electronic health record login screen, so it's real. This is laboratory, low ink, Radlex is radiology, and SNOMED is doctors talking to the computers, so the computers can understand the doctors. And then there's the training agenda. So not so much we're doing the training, but do we have a good training program? What training is needed for what application we're actually going live with? And then now the types of learners, measurements, what is best? So training methods, we have computer-based learning, which is good for people who are remote or work part-time, or so they can do it on their time. But it's also good to have CBL learning as a prerequisite before you get the hands-on training, because now you understand what the trainer's telling you and what screens you're in. So this is going to be good. But you also have hands-on, also have train the trainer. You also have super users. So that's part of what you're doing here. Then you're going to look at image management. The entire life cycle of an image. This is 24 questions here. It's a very big part of it. So you're going to learn the whole pathway from the time an image is created to the time that you no longer need it. So it's going to follow. I've heard that people say that in an image's life cycle, it's going to be touched or moved 27 times in the average lifespan of an image. And you're going to say, that's crazy. That's a lot of times. Well, think about it. It's a brand new image. Then the next time you pull it, it's a prior. Then the next time you pull it, it's the prior of the prior. And then you're going to export it to someone else who's going to do the same thing. By the time you don't want that image anymore, 27 times. Now, some of them are more. But now we're looking at all of the things, post-processing, the human interface, the workstations. We're going to look at the environment, how to export, and then also the different kinds of enterprise imaging we do. Input devices, you have your monitor, your computer, your microphone. We're going to learn what the right types of things are for that so we can go back and fix them. You're going to learn image display QC, how to know if you got a good image or not. We're going to use these tools like calibrators. We're going to look at image quality. We're going to look at test patterns and all the things we got to do, because we're regulated by Joint Commission of Accreditation of Hospitals. We're regulated by the FDA and also the ACR. So we're going to have to prove that we have a quality system. And how do you know? That's how we're going to find out. And then you're going to have to learn also what some of the IHE standards are. How do the different systems talk to each other? Like, how does the PowerScribe dictation system know that there's multiple images for the doctor to read? And how does it know that the image is being displayed the same way that it was on the modality, the same way that it is technologist workstation, the same way it is in the radiologist workstation? You don't want to have any discrepancies. So we have frameworks and ways that make this work right. And when we learn those, that's how we can tell what to fix. Then IT, you need to learn something about IT. There's a little more in this course. Basically that one, IT is something you're just going to have to learn by doing. You can get some good instruction, but you have to be immersed in it somewhat, at least before you really understand it. But you know what? It isn't required that you understand IT that well. Just understand how to understand how it works and be able to describe your problem, and then go and get the right IT specialist to help you make that reality. So architectures, then you have what types of storage, you have what types of network protocols, what types of archives, all the stuff I was telling you about, cabling, different types of networks. See these? They were in there again. And then you look at how to break down a workstation, how to break down a server. And then there's another page, authentication, how you sign in. Make sure everybody's supposed to be in. Then retrieve data, and then also standards, and then how you plan for obsolescence, because every time you plug in a computer, it's already starting to obsolete. So you got to plan for when you need another one and when you do this. We're also going to look at what's in the box, your CPU, RAM, video cards. So I got a picture here. I have lots of pictures in the course. So those people who are visual, it will help you try to go to that box and say, oh, I remember he said these long things right here are memory sticks. Okay, I get it now. I know that's what needs to be replaced. Now we're going to look at how the network works in the entire hospital. I did show you earlier in the beginner course. We will have a review to that, but now I'm going to put it all together with the outside users and how they communicate with the servers, how it communicates with the storage, how remote users, how wireless users. This is how it's all put together, and we'll go over it. But then also know how to know when the network's not performing right, how to tell. We have a lot of data going in the funnel, and bandwidth is the maximum amount that can be transmitted at one time. It doesn't get any bigger. So if you're sending more data on the same network, eventually it's going to get slow. So you've always got to be ready for that. And then latency is how much time it takes for this data to get from here to here. And if that has to retry a lot of times before it finally gets there, takes longer. We call that increased latency or packet failure. So a little taste of what we're talking about here. So also system management. Right now you have to determine how long can you be without access to the data. Then you design a system that can meet that need. If you're a stroke and trauma center that serves most of the city, then you really can't be out without the data that long. So you might want to have a whole second data center. This was actually the view outside my office window when I was PACS administrator. So that helicopter coming in, we have to make sure that patient is going to be able to get the care they need. They don't not care if your PACS is down or not. So we have to come up with a way to get them back. Now in system management, we also look at what happens when you add new technology. When we had to go to 64 slice, maybe 256 slice CT scanners, that gave us a ton more data. Now we're starting to do mitral valve replacements. Those have 8,000 slices in them. You can't just let your PACS absorb that and not understand that you're going to have to increase your archive space. You're going to have to get more network. But we understand by our training that we can go and sit at the table and say, all right, you're going to put that CT scanner on, or you're going to put 5 of those on. Then here's what we're going to have to do to the infrastructure to support that. And you do it before you install it, so nobody ever has to see it slow down. Then data migration. When archives don't run forever, you're going to have to go get that data off of them and put them on something new. Or if you buy a new PACS, you're going to have to get the data out of the old system. So this is another big part of the job. So you're going to learn, one, to get the data of one place to another, but then also tell, did you get it all and is it usable? And if not, you make them go do it again or find out what to do. Now we get into also clinical engineering with the support for the modalities. This is the DICOM objects. We're now looking at them as objects. We're not looking at them as data flowing on a wire. So modalities, yes, or something you put a patient in, the human component. I am a technologist. I used to make images on patients, so I understand that part. But now we're looking at it from PACS administrators as all the data that we're moving through and what its purpose is. We're going to go into how the CT scanners are put together and how they work and talk about some details, like what the gantry is that holds everything, what the tube is doing inside there. Because if you're an IT person, you probably don't know this, and the test will ask you certain questions about the modalities. Now, it's not going to be a lot of detail, but you at least know how to be able to carry a conversation on or know what a technologist is trying to tell you. Then we're going to look at hazards. We have to be aware because not everybody thinks about it. But when we're putting a system in, we also need to look at, is it going to cause people any danger? Now, most of the time, the computers aren't going to hurt anybody, but we look at what they connected to. We put a computer in that room and it gets sucked in the magnet. Whose fault is that? We should have thought and planned better. And I know these are always hilarious when you see this happen, but you know what? It's not so hilarious if there's a patient in there. So we don't want that to happen. Then there's the good part, the medical imaging informatics. All the other things I showed you were the action. These are the things that happen out in the field that you're going to be walking around and make working. Now this is the thinking part. This is the part where you have to understand all these different terminology and what they mean and how to move the data in these formats and make a workflow, make a computer talk to another computer. Now you're not going to have to do this by yourself. There's a team of people out there that you're going to work with. You just have to tell them what you want and know how to tell them that they've done it right. Because, think it's just like, you got a train conductor. You're going to say, all right, jump on that train and make it go. Yeah, they can do that. But did they start when you asked them to? And did they end up where you wanted them to? That is where the PACS administrator drives the PACS system. They get these people who can make it happen, but somebody has to have the vision of what's needed. All right, and then you have the integration profiles. That's what I was telling you about, you're going to have to understand the workflow and why one computer system knows what the other computer system's talking about because the programmers wrote it that way, and they use the IHE profiles as a starting point for that software and that programming. That's every step of the image lifecycle. Then these are the integration profiles that are part of the IHE. So this is very good test material right here, so it's important to learn that. But when you understand what these each are trying to do, it becomes very clear, how the system works. And then there's the part 3. This is something that's taught not by me, but someone else. I guess I should have put his name. And this is the deeper dive in DICOM and HL7. So, for right now, the other parts right there, we kind of just glossed over it because you really don't need a deep understanding to be able to functioning PACS administrator. But if you're going to be one that's expected to troubleshoot with the engineering staff of the vendor, then you're going to need to understand what they're trying to ask you for and how to get it. So you're going to look at the DICOM services, which is the C-Echo, C-Store, C-Find, all of the different class services that you're doing. I know that's not plain language. I hate to break it to you, but DICOM is an international standard. So we write it in language that can translate easily amongst the world. So the programmers will understand what you're trying to do, because we all know when we go to different countries, sometimes the translation doesn't make any sense. And we don't want that to happen on this system. So that's why we're going to be using new terms you've probably not seen before. Application entity is what we call the thing sending data, and application entity title is what the name of that thing is. DICOM association is the connection. So we're going to learn how DICOM works, how something sends from one thing to another, and how you can be one vendor in the imaging machine, and the archive can be another, and the doctor can be using a workstation from someone else. And it all works. And then there's HL7, where you got the pipes and hats, all the different, how you can understand what you are trying to find out in this message set. HL7 is the standard amongst most all of the different IT systems in the hospital. And then you have what an HL7 workflow looks like. You're looking for an order, and you're going to say, my provider is not really, is picking the wrong data. I need to make it somebody else. So they're going to go in here and they're going to reprogram it. And that's so you don't do that. You got to ask somebody to do that. You're HL7 people, unless you want to become one. And then here's what an order message looks like. You're going to find it right here. This is a PowerScribe order message. It's getting it. And right here, and then here's all the different elements used by most departments, but not dependent on PACS. But PACS is dependent on the order. Remember, we don't do anything unless the order triggers it. That's what makes modality work lists kick in, is this message right here. And then when you get a report, it's signed in PowerScribe, then it's going to be an ORU, and it's on its way back to the archive. It's on its way to the EHR to tell everybody what they said. And so that is the two parts of HL7. I'm just giving you a little taste of what this is like, how things work. And then here's the big taste. This is the gulp right here of what you do with the HL7 information. So you don't really need to worry about all of this, but you do need to understand about the parts that you work on, like the EHR, the dictation system, and the PACS system right here, and what messages that they need and when they need them. And then basically here's the integrated workflow. Remember I teased you with that diagram. So we're going to say we first get an ORM message. It's going to go and trigger a DICOM message to be retrieved from the archive. It's going to send an ORM message to the modality work list so you can see it. The image will be matched to that ORM and then sent to the servers. And then the technologist is going to use the DICOM store. The images are going to be on their way to be available to the workstations. And then it's going to be routed maybe to an outside PACS if you have third-party radiologists somewhere else reading, or to a cloud system. And then you're going to trigger image sharing. The third-party interfaces, you might have lasers, you might have robots. They're going to all get their information. And then now the image availability notification, that's an HL7 message. It's going to go out and tell people the images are here, and that's how the links get to the web clients, how you can see an image to the EHR. And then the dictation report's going to be done when the radiologist reads it. It's now going to be an ORU message from HL7, and then it's going to send it an ORU message to the PACS.